In this lesson, we're going to learn how to factor trinomials. We've factored various things so far. We'll expand out now to trinomials and different types that we haven't covered already. So just as a recap, in the problem ax to the second power plus bx, we learned to factor out the common factor, which in this case is x, and our answer would be x times the quantity ax plus b. Likewise, in the second example, 2x to the power of 4y squared minus 6x third, both terms have a factor of 2 in common, and they have a factor of x to the third in common. So that's what we would divide out, and we would get 2x to the third times the quantity y squared minus 3. So we learned how to do that, and we learned how to check our work. And to check the work, we could multiply back together to see if we get the original amount, which we would. There's other types of problems that we have to look at, and factors don't necessarily have to be just variables or numbers. They could be expressions. So in the problem 2 times the quantity x plus 1 minus x times the quantity x plus 1, we can clearly see that in both terms we're multiplying by x plus 1. So the common factor there of x plus 1 can be divided out. So in this case, if I divide x plus 1 out, or in other words, if I undo the distributive property, the x plus 1 would be divided out, and I would be left with the 2 minus x. So one of the things we want to look for today are common factors that are expressions that we can factor out. That's going to be a key part of today's lesson. Lastly, we could also factor by grouping. So I know this is about trinomials, and here we have 4 terms, but we can still factor this. So when we're factoring by grouping, there's various ways we can do this. As I look at this problem, I see the 14 and the 7 are factors of each other, and the 4u and the 2u are factors of each other. So I could rearrange this, because we can use commutative property. I could rearrange this, and I would have 14 minus 7v plus 4u minus 2uv. And then I can group the terms that I want to factor. So within the 14 minus 7v, I can divide both of those by 7. And when I do that, I would be left with 2 minus v inside. In this expression, I can divide by 2u. And when I do that, I would end up with 2 minus v inside. And now we can see, look, we have an expression that is a common factor. So as we did up above, I can divide both terms, the 7 times the quantity 2 minus v plus 2u times the quantity 2 minus v. I can divide them both by the 2 minus v. I can undistribute that, and I'm left with 7 plus 2u. And that would be my final answer. In the next problem, it looks like we have common factors. Y minus 1 and 1 minus y are very similar. The difference between them, though, is that they're exact opposites. We've got a positive y and a negative 1, And here we have a positive 1 and a negative y. Well, we're not at a loss here. We can actually do something with this. We can manipulate this expression here. So the 1 minus y, they actually have a common factor. Anything can be divided by 1 or multiplied by 1. Likewise, it can be divided or multiplied by negative 1. So I'm going to divide this term by negative 1. I'm going to pull that out. So when I do that, I end up with 3 times the quantity, y minus 1, minus the 10y, times negative 1 times negative 1 plus y. Right, so this is the part that changed. I undistributed a negative 1 to get this term here. And if I was to multiply the negative 1 back, I would get my original expression back. So now we can continue here, but I'm just going to rearrange this here so it looks like the other side. So this is 3 times y minus 1 minus 10y times negative 1 times y minus 1. And then I'm going to simplify here. 3 times y minus 1 plus 10y times y minus 1. And now we can see, look, we can definitely pull this out. We can divide it out, undistribute it. I end up with y minus 1 times the quantity 3 plus 10y. And that is my final answer. Finally, we're going to move on to factoring trinomials. And they're going to take the form of x squared plus bx plus c. B is just the coefficient of x. So in the following problem, here's our x squared, here's our bx, and here's our c. Now the way that we're going to handle this is that you'll notice there's not really any common factors we can divide. So there is a method we can use, and here's what we're going to do. We're going to look for factors of c. So numbers that multiply to produce 56 that also add up to 15. So I'm going to write that down. Factors of c whose sum equals b. So let's take a look at that. Factors of 56. I'll just make a list. We could do 1 times 56. We could do 2 times 28. But neither of these add up to 15. Right? 1 times 56 is 56, but 1 plus 56 is 57. 2 times 28 is 56, but 2 plus 28 is 30. I could keep going. 4 times 14, well, that adds up to 18, so we're getting closer. Finally, we get to 7 times 8. 7 times 8 is a product of 56, and 7 plus 8 is 15. So now I found my factors of c whose sum is b. I'm just going to rewrite the problem. X squared plus 15x plus 56. And we're going to use those factors that we found to create an equivalent expression but it's going to be expanded. So here we've got plus 7x plus 8x. So there's the 15x broken out, plus 56. It didn't matter if I put 7x plus 8x or 8x plus 7. Doesn't matter. But now that I have this expression, I can use the grouping that we used earlier in the notes to factor this even further. So I'm going to factor x squared plus 7x. I'm going to group those, and then I'm going to group the 8x plus 56. And within each of those parentheses, there are greatest common factors. So with x squared plus 7x, I can factor out the x. I'm left with x plus 7. And with the 8x plus 56, I can factor out the 8. And that is also x plus 7. And now you can see, look, we have that common factor of x plus 7. When I factor that out, I get x plus 7 times the quantity x plus 8, and that is the answer. On the next problem, we have a similar type of trinomial, except now we're subtracting in the middle term. In the last problem, everything was addition, but we're going to handle this much the same way. We're looking for factors of c whose sum are equal to negative b. In this case, that means we're looking for factors of 12 whose sum is negative 8. Well, negative 6 times negative 2 equals 12, and negative 6 plus negative 2 equals negative 8. So negative 6 times negative 2 are the factors we're going to use. So this part of the work requires maybe the most thinking. X squared minus 6x plus negative 2x plus 12. And now again, we can group these. And we can factor from there. My common factors now are x minus 6. So when I pull those out, I'm left with x minus 6 times the quantity x minus 2. I'm writing this one as subtraction, even though there was the addition sign there, because sometimes, or most times, people will prefer the subtraction as the simplest form. However, x minus 6 times the quantity x plus negative 2 is an equivalent expression. In our final problem, we now have all subtraction. So we're going to start by looking for factors of negative 5 whose sum is negative 4. We could say, well, negative 1 times 5, that equals negative 5, but when I add those together, I get positive 4. So it must be the opposite way around. It's 1 times negative 5. That does equal negative 5, but when I add them together, I get negative 4. So we're going to break the problem up as x plus 1x plus negative 5x minus 5. And from here, we can now group our problems. So I'm going to group these two and these two. In the first expression, or the first term, we have a common factor of x. So that would be x times the quantity x plus 1. In the second expression, we have a common factor of negative 5. And when I factor that out, I also get x plus 1 as the factor in the expression. My common factor now is the x plus 1, so I'm going to divide that out, undistribute it, and when I do the distribution, or I undo the distribution, I'm left with x minus 5. And there's our final answer. So these are the types of problems you have to do today. If you need any help, let me know, and I'll get back to you as soon as I can.